All right, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great event on tap. I am super excited about this one. Before we get started, though, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for either of our speakers, please don't wait, don't hesitate. Just use the question and answer tab on your interface and submit your question, and we'll try to get to as many as we can near the end of today's webinar. We also have a very interactive chat interface, and we encourage you to chat out your comments, suggestions, questions, etc., whatever you want to share with us during the webinar, and we'll maybe address some of them during the webinar. And also at the end of today's webinar, we are going to be doing a drawing for $100 Amazon gift cards. So stick around. Hopefully you will be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is Managing and Optimizing Container Infrastructure at Scale. Our speakers today are Jay Subia, who is the Senior Solutions Architect at Red Hat, and Chuck Tatham, who is the CMO and VP of Business Development at Densify. Gentlemen, thank you so much for joining me today. I really do appreciate it. I think we actually lost Chuck very briefly here, so hopefully he'll be joining us very, very quickly. But Jay, I know you're going to be kicking us off anyway, so I'm going to take myself off camera, put myself on mute, and let you get right to it.
Thank you. Thanks, Charlene, and hello, everyone. I'm Jay Subia from Red Hat. Today I'm going to talk about OpenShift Container Platform, and the agenda is like, first we are going to do some introduction on OpenShift, and I'm going to talk about how we can able to manage the resources with OpenShift and the common challenges that we face. And then there'll be an introduction on Densify and how Densify and OpenShift in the combination can deliver successful resource optimization techniques. And then we'll also have a Q&A. First, I'm going to just give you an overview of OpenShift. So enterprises across are using microservices and containers to build applications faster, but for that they need a right platform. And Red Hat OpenShift is the Kubernetes platform that provides a trusted foundation to deploy the environment on-premise, hybrid, or multi-cloud environments. Red Hat OpenShift also provides an automated operations and a streamlined lifecycle management that empowers the development team to build and deploy their new applications, and also helps operations team to provision, manage, and scale their Kubernetes platform. Development teams have access to validated images and solutions from hundreds of vendors with the security scanning and signing throughout the delivery process. They can also access on-demand images and get native access to variety of third-party cloud services, all through the single platform. And the operations team can also provide a visibility into deployments wherever they are with their built-in logging and monitoring. Red Hat OpenShift operators embed the unique application logic that enables services to be functional using performance and updated and patched from the operating system. That Red Hat OpenShift also supports tooling, development tooling like Python, Jenkins, and Java, and more to help the developers to build their new applications. OpenShift also provides built-in logging and monitoring, registry, router, etc. on top of the Kubernetes platform. It is built on CoreOS, and it also provides a service mesh for the developers to manage their application microservices. And this is the architecture overview of OpenShift. You can see that we have the master nodes, like it's a control plane node where all the basic Kubernetes services and the HCD database, which is like a key value database, is deployed. And it also has OpenShift API API services that are deployed on the master nodes. And the worker nodes will have a router or the registry, OpenShift registry, then the logging like Kibana, Elasticsearch, Fluentd, and the gap tools like Prometheus, Grafana Alert Managers are all deployed on the worker nodes. And workloads or application workloads are also deployed on the worker nodes. And the developers can able to access the platform using their development, the DevOps tools. They can also integrate their existing DevOps tools with the platform. And the administrators can also use their existing automation tool sets to manage the platform. And just I'm going to talk about, give a core concepts overview, like what is container. A container is smallest compute unit, and container is created from the container image. The image is deployed on the image registry, and there'll be like a multiple versions of image registry. You can deploy it on multiple versions of images. You can deploy it on the image registry. And each pod will have either single container or multiple containers, and the pod will have its own IP address that the containers share the same network IP addresses. Deployments is what the application team can use to deploy their application, and it defines how the applications get rolled out across inside the platform. And it will also define the versions of the application, versions of the images that will be used for the application. And then project namespaces, OpenShift namespaces are used to isolate the applications across the environment. So, for example, if there is a namespace called payment dev, and you have an application team that assigned for payment dev, they may not be able to access other namespaces unless you provide the access to them. So that kind of isolation is provided within the OpenShift by default. And services is being used for the internal load balancing and to discover the pods. So a request will go to the service, and the service will load balance the request across the number of pods that is running behind the service. And you can also use the service to talk. The application can talk to each other with the service. So if there is a front-end application and you have back-end application, if you want to give the back-end application URL to the front-end application, you can just give the service URL. The front-end application can talk to the back-end application using the service URL. The request will get load balanced across the multiple pods. Router is used. Routes are used to access the application that is deployed on the platform from the outside of external to the cluster. So the route will send the request when you hit the application URL. The HTTP request will be sent to the route. Route will send the request to service, and service will load balance the request to the containers, backend containers. And now let's talk about the OpenShift pod scheduling, right? So this is one way of designing your environment. Like let's say like you have a stack of servers that are defined on zone 1, right? So, and then you have other stack of servers on zone 2. You don't want to run all your application pods on zone 1, because if that stack goes down, then your whole application might get impacted. So you might probably need to configure your application so that there is something called anti-affinity rule that you can configure in OpenShift, so that no two parts of the same application can be deployed on the same zone. So in that way, you make sure that you have the high availability for your application, so that if there are like 4 pods running for your application, all the 4 pods will be scheduled on 4 zone. So all this can be achieved by labeling those nodes. The nodes that are sitting on zone 1, label those nodes as zone 1, and zone 2 as zone 2, is like zone 3 and zone 4. So when you are configuring the anti-affinity rule, it will make sure the OpenShift scheduler will make sure that the pods won't get deployed on the same zone. In case if you are deploying 5 pods, then it will just make sure that 4 pods get deployed on the 4th zone, and the 5th pod might get deployed wherever the resources are available. And the load balance is in such a way that when you are hitting the URL, it will first go to the load balancer, and the load balancer will send the traffic to router, and then from router to the service, and service to the other services, etc. And then let's talk about quotas and limits, right? So when you are onboarding multiple applications, when you are onboarding like hundreds of applications or hundreds of application teams getting onboarded on OpenShift, you need to make sure that each application team can use the specific number of resources. You can able to do that by assigning quotas for each namespace where your application team has been given access. So in this example, you can see that I have an application namespace called Payment Dev. A project has been created for Payment Dev, and I have assigned a CPU of 4 CPU for that project. And I am running 3 CPUs, 3 pods on that namespace, and 3 CPUs have been used in that namespace. And I have another application namespace called Catalog, and I have assigned 5 CPUs for that namespace. 3 pods are running on that namespace, and 2.1 CPU has been used by that namespace. Now, the application team, Payment Dev application team, is trying to deploy a new pod, and they have, that new pod has 2 CPU requests. Unfortunately, Payment Dev does not have enough CPU available. So now, as a cluster administrator, you need to make sure, you need to check which namespace is using less CPU. You can see that Catalog is underutilized. You can reach out to the Catalog application team, ask them whether you can take that CPU and give it to Payment Dev. If they're okay, you can just reduce this number of CPU in Catalog and give it to Payment Dev. So this is just an example, and it is very easy if you are only managing like 10 or 20 namespaces. If it will become hard when you are managing like 100 or thousands of namespaces in the platform. And this is like a command that you can execute in order to find out what is the current quota that is being used by the particular namespace. In this one, you can see that 15 CPU has been assigned, and there are like none has been used. So this is the command that OpenShift has been. You can use the OpenShift to get the current status of the quotas used by each namespaces. You can also use Prometheus tool to get the report. But as a cluster administrator, it is your responsibility to manage the resources across the platform. And this is the another thing, like a node pod scheduling. So when a new pod gets scheduled on the node, you can see in this example, we have node 1. Node 1 has 2 containers already running, and it can run 2 more containers. And node 2 has 3 containers already running, and it can only run 1 container. If there is a new pod that has 2 containers that get deployed on node 1, that needs to be deployed, it cannot be deployed on node 2, does not have enough resources. It needs to be deployed on node 1. Now, as a cluster administrator, is responsible to make sure that if there are more number of nodes, CPU or resources, any other resources exhausted, you need to scale the cluster. Right, so there are like automated, OpenShift provides automated way to scale the cluster using the APIs like AWS or Azure or VMware vSphere APIs. You can scale the clusters automatically, or you can manually scale the cluster using those APIs as well. But as a cluster administrator, it is your responsibility. Cluster administrator is responsible to make sure that the number of nodes are always available, and it is not the CPU or any resources are not exhausted on the nodes. Okay, so with that, I'm just going to hand it over to Densify, and then where they're going to explain how Densify can complement OpenShift, how it can able to help a cluster administrator to manage all these resources using the software, and how they can able to deploy it or get the report of the current utilization and the future utilization, how they can able to optimize it.
Okay, Chuck is having trouble reconnecting, so we do have John DeFazio on the line as well. He is from Densify, and he's going to take over for now.
Yeah, so what do I need to do, Charlene? I just need to share my screen?
Yes, I believe so.
Share screen. Share. Okay, so I'm sharing it now. Can you see it?
Not yet.
Oh, never mind. I have to hit another button here.
Okay. All right. And while that's coming up, just a quick reminder to the audience, if you have a question at any time, you can go ahead and use your question and answer tab to submit your questions, and we'll try to get to as many as we can near the end of the webinar today. All right, John, your screen is up and you're ready to roll.
Okay, great. Well, thank you very much. And I'm pinch hitting for Chuck. My name is John DeFazio. I work actually for Chuck, so I'll do the best that I can. As Jay just described, container resource management from our perspective is very complicated. Namespaces, nodes, pods, deployment, resource management, etc. And in a very simple way, the world of containers is extremely complicated. So basically, what we're looking to do is, if resource control is left to humans, it's going to be a mess. So what we're trying to do is say, from our perspective, if you're trying to contain cost and risk, the majority of those decisions have to be automated. Because as Jay said, if you're managing 10 spaces, namespaces, fairly straightforward. You're managing 100 to 200, it gets very complicated very quickly. And we also believe that you need an engine that can precisely determine what those resources are. Most individuals, when they're provisioning resources, the last thing they're going to do is try to figure out what's the optimum. So they typically go for the biggest, and that generally works. So at Densify, we believe that the analytics that we generate for these resources are very precise for the best optimization of performance and cost. From our perspective, you got container resources, that you got nodes and scaling of those resources. You've got cost and procurement. So we look at this as a Venn diagram, where if you are trying to manage one at a time or two at a time, it's going to be a challenge. So we believe that you must do them all together. So therefore, you can't optimize nodes if container resources are incorrect. You can't optimize purchasing if the nodes are incorrect. And what happened here? Oh, there we go. Sorry, operator error. And you can't allocate container costs without understanding what these resources, details, quotas, limits are. So we believe that the intersection of all three is where you must be to optimize and analyze all these things appropriately. So the Densify optimization engine works in that space. Basically, what we do is we understand and drive application demand patterns of those workloads, specifically for multiple compute resources like CPU, storage, I/O, etc. And we built a predictive model that basically will say, here's how this workload is behaving over the course of a typical day. What you see on the left here is 24 one-hour time slices of that application, specifically for those compute resources. We also understand all of the infrastructure attributes that are out there. Public cloud, containers, on-prem VMware, and we normalize all of those resources such that no matter where you're running today, no matter where you want to run tomorrow, we can do analytics that basically say, if you've got an AMD chip on Amazon running 8-core processors, what's that equivalent to an Intel chip running on Google as an example. We also look at individual client tags and labels. These are the things that, as Jay was saying before, affinities, anti-affinities, et cetera, what needs to work together, what has to be optimized together. We also look at if a client has specific billing data. You might have a special pricing arrangement with one of the cloud providers. And are really the thing that drives all these decisions is the client's policy. What's fit for purpose? What overcommits do you have to have? What utilization is upper limits, et cetera. So all of those, individual components factor into these decisions. And what we believe we do is we provide visibility. We've got a little dashboard here. What we look at is balancing performance, and that's the little orange dashboard, with cost. So if you're looking at resource requests, and we're going to make sure that performance is the key to make those things run correctly. And then, by the way, we're going to the cheapest version of what that can be. From a node perspective, same thing. You know, if we're upsizing nodes, downsizing nodes, et cetera, we're going to look at it from a performance perspective first. Am I getting feedback? Okay. And finally, you know, charging back and billing specific. A lot of individual applications that say they read the bills don't actually tell you what to do about them. So we provide visibility to the bill. We also provide recommendations on how to reduce that bill. And one of the things you see here is that, you know, we've got specific capabilities for outlier detection. Basically, you know, you've been averaging X amount of dollars per month, and in last month you spend 2X. What happened? We do a very detailed analysis of what happened, why it happened, what you should do about it. The key here is that we also recognize that as an engine and as a brain, we have to fit in with the client's infrastructure. So we don't dictate, you know, what platform you run on, where you run it, et cetera. We want to make sure that we fit into the current environment, the potential future environment, what other data sources you might have, what ITSM ticketing systems. So for example, as I mentioned in the beginning, you know, we believe that at scale you need to automate. So if we're making recommendations and dropping them into a ticketing system to open up change requests to get stuff done, that's the best way to do this stuff. We can also export to your favorite business intelligence software. So if you don't like the way the portal is organized, we can export that information to specific business intelligence software that can be customized for the client. We work with a large client that customizes it such that it's showing by vice president what their billing was, and how they're doing. So kind of creates a little bit of a competition inside the company. Infrastructure as code. We also believe that if you make the change based on a recommendation and you don't incorporate that into the provisioning of the next system, you'll basically just go backwards. So we integrate with Terraform, Ansible, CloudFormation, et cetera.
Hey, John.
Sorry?
John, it's Chuck. I'm back.
Oh, Chuck, you want to take over?
But you're doing fantastically, and I'm not sure my audio is okay. Is it okay?
I can hear you just fine.
All right. Well,
hey, I said I was a pinch hitter. I will never usurp the expert here. So
you're doing a fantastic job. I'm happy to speak forward if you build the rest of this slide.
Okay, yeah, go ahead, take over, and I'll just continue to advance so you don't have to.
Yeah, you'll have to control the slides for me.
Okay.
So what John is laying out here is that Densify as an analytics engine is really all about providing the answers around optimization and making them available to the systems and processes that require them. And John did a good job of covering them. We don't want to conflict with anything that might be in the environment, including things like OpenShift, of course. But if you go to the next slide, John, that transparency and efficiency, or rather precision, keep building this slide, just build it out completely, is what allows us to drive automation. So once you have a precise answer, we're able to integrate at the code level and remove the burden from the humans to have to specify those resources. And what we do is, you see that line of code, or the couple lines of code at the bottom, is we basically variabilize the resource specifications. So the human can build their code and worry about building business value, and Densify will deliver the ongoing optimization answers. And that can include, of course, ITSM, change control. Build a little further, John. We like to call this CI/CD CO for continuous optimization. And so I think there's 2 more clicks there, John. We bring the precision of the answers, we get it into the pipeline through those integrations, and we ensure that it's all transparent to the application owners who have to approve of the changes to their infrastructure. I'm sure John did the intro as I would normally have, and talked about the importance of getting the optimal answers driven in a software driven fashion versus relying on people to do it. Okay, next slide, John. So that's the Densify story. We have, over the last year, partnered very closely with Red Hat in order to ensure that all of our certifications are in order, that if you are a Red Hat customer and you leverage Densify along with your Red Hat investment, we are OpenShift operator certified, container certified, we're available on the marketplace, so very Red Hat friendly. And I think the next slide, John, is really a Q&A, or actually you may not have, oh no, you do have it. Charlene, we can go to Q&A if there are any, but I would like to point out a couple of resources. One is an upcoming webinar on the 14th, all about using Densify integrated to Helm as part of managing a container infrastructure, and our free trials, which no strings attached, 14-day free trials if you want to run the analytics in your infrastructure and see what Densify says could be done to improve. It's a great way to engage, and there is very little downside. It's kind of like radiology for your infrastructure. We'll show you everything we find as part of getting to know Densify a little better. So apologies for the technical troubles here, all on my end, and some work to do here on my infrastructure.
I love that, radiology for your infrastructure. That's I like that. I like that a lot. So yeah, we have plenty of time for questions, guys. We've gotten a couple in, but if you have a question for either Jay or Chuck or John, you know, depending on who's going to show up from the Densify side, please go ahead and use your question and answer tab and get it on in. You can also use the chat tab and put it in, and we'll be happy to move it over for you. Here is a question for you, Chuck. How does Densify gather the metrics needed for container optimization analytics?
Densify in a container environment will generally rely on something like Prometheus for its data. So part of our deployment would be assisting in getting Prometheus configured correctly and feeding the data we need. We do, though, as was shown in that high-level integrations diagram, have the potential to feed off other data sources. The caveat being that good analytics require good data in. So if you've got quality time series data in a readily available source, we can use that. But most commonly, it's Prometheus.
Okay. All right. Here's a question that came through, and Jay, you already answered it written, but I'll go ahead and ask it for the benefit of the rest of the audience. Is it possible to have 4 nodes, or to have nodes with different capacity? One could host 4 containers and other host 6 containers.
Yes, it is possible. So just need to make sure that you, as I said, like as a cluster administrator, we have to make sure that design the architecture accordingly so that you can able to deploy, onboard your applications seamlessly without causing any problems to the application teams. So you can have like 16 cores, worker node and 32 core worker node. OpenShift will automatically able to pick up the number of resources available, and it can able to add it to the pool.
Excellent. Excellent. Okay. Next question here. Can Densify be applied to more than just container infrastructure?
Actually, Densify as a technology was developed and proven on-prem in large-scale VMware infrastructure, so traditional virtualization. And we have, over the last 2 years, brought it to market as a SaaS product, and I've done a lot of engineering on optimizing public cloud, so IaaS and related capabilities, as well as managed Kubernetes, Kubernetes on-prem, and in the cloud as well. So
all right.
it's single solution. You could have a view into your VMware infrastructure, let's say your AWS, Azure, GCP infrastructure, as well as variants of containers as well.
Okay. All right, great. Let's see. Plenty of time for questions, guys. If you do have one, go ahead and use your question and answer tab. Here's another one that just came in. How does Densify address seasonal differences, especially if it has not yet observed a peak season?
It's a great question. Densify will observe and build a predictive model from the behavior that it sees over time, and that's great if the thing existed and has a lifespan for us to watch over. For new placements, we tend to prescribe something we call a soaking pool model, which says you don't really know how something's going to behave if it's brand new. So why not over provision, give it lots of resource, watch its behavior through business cycles. And after you've watched it long enough, and that is a setting in our policy engine to say how long we should watch something before we make a decision on it, then Densify will give a recommendation. So it's actually a very conservative approach that allows us to rely on watching something empirically before making a decision.
Excellent, excellent. Okay, let's see. We have one more question here. So if you have a question, please don't wait. Go ahead and get it on in now. I'm sure we'll have plenty of time to address all the questions that come in here. The next question I have for you is, how is Densify priced?
Well, a question we like to have. So Densify is SaaS-based, so it's delivered as a service. It requires a small forwarder on the environment. It is price based on the number of entities we are analyzing. So if you thought of it in the world of containers, we're basically looking at the scale of the environment and basing our per entity per year price on that volume. So the bigger the environment, the lower the price per entity. And it's always a subscription-based model.
All right. We did just get another question in here. May Densify be applied to multiple container infrastructures, and will they appear in the same dashboard?
Yes, and our extensive labeling and tagging capabilities allow you to apply any additional data into the environment so that you can slice and dice in ways that make most sense for your business. Yeah, I mean, you could have container environments on different clouds. You could have them on-prem and off. It's all within the same deployment.
All right. All right. So that is all the questions that we have right now, but I'll leave the question and answer tab open for a few minutes and see if we get any other last minute customer questions in or audience questions in. Meanwhile, just a quick reminder that today's event has been recorded. So if you miss any or all of the event, or if you just want to watch it again, you will have the opportunity. We will be sending out an email after the webinar that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website, so you can go find it there as well. You can just go to devops.com/webinars and look in the on-demand section, and it should be right there waiting for you. Okay, still no additional questions from the audience. So like I said, I'll keep it open. We'll go ahead and do the drawing for the 4 $25 Amazon gift cards. Or not 25, $100 Amazon gift card. Sorry about that, guys. These are the big ones. Yay. Okay, our first winner today is Tad L. Congratulations, Tad. Our second winner today is Claudio V. Congratulations, Claudio. Our third winner today is Alexander D. Congratulations, Alexander. And our fourth winner today is Matt D. Congratulations, Matt. We'll be following up with all four of you by email to get your Amazon gift card over to you. And so check your inbox. If you don't see anything there, please check your spam folder. Well, we are not getting any more questions in, so I guess you guys have done a great job covering all of the technology, the Densify technology, and how it works with Red Hat OpenShift. So thank you very much. And thank you to everybody who did submit questions. Those were some really good ones. If you have any last minute questions, right as we're shutting off the webinar, you want to go ahead and send it in, that is fine. Go ahead and do that. We will get your question answered, even if it's not during the webinar. The folks at Red Hat Marketplace will be getting a copy of all the questions that came in, and I'm sure they will be more than happy to follow up with you and get your question answered. Excuse me. Jay and Chuck and John, for that matter, thank you all for such a great presentation. Good stuff all the way around. It's great technology and you know, very well received by the audience. So I'm excited by it. So thank you very much. I appreciate your presentation today.
Thank you.
Thank you for having us, and apologies for the technical difficulties again.
Oh, it's no worries at all. No worries at all. I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody, and please stay safe.